Hi everybody, welcome back to my channel on Feynman integration. Today we won't actually be solving an integral using the Leibniz rule. We're going to be discussing a property that will be used in later videos. That property is King's property. It states this: the integral from a to b of f of x dx is equal to the integral from a to b of f of a plus b minus x dx. And mostly we're going to be using this special case right here. That states that the integral from 0 to pi over 2 of a function of sine of x dx is equal to the integral from 0 to pi over 2 of that same function, but evaluated at cosine of x dx. And actually, I should have written here that this would be a function of sine of x and cosine of x, and therefore this one would be a function of cosine x and sine x. So basically, you just replace all instances of sine x in the first integral with cosine x, and all instances of cosine x with sine x. And I'm going to leave it to you to figure out why that's true using the general case of King's property. So just plug in the values and work it out. You'll see that that is true. Some examples of what that means is like the integral from 0 to pi over 2 of e to the sine x dx is equal to the integral from 0 to pi over 2 of e to the cosine x dx. And also that the integral from 0 to pi over 2 of the inverse sine of cosine x dx is equal to the integral from 0 to pi over 2 of the inverse sine of x dx. This, of course, is just equal to the integral from 0 to pi over 2 of x dx, because if you take the inverse sine of the sine, you get the function itself. And this evaluates to pi squared over 8. So that pretty difficult integral right there was made super easy using the special case of King's property. That would have taken you 20 to 30 minutes to integrate it by parts and do some fancy pants algebra, and then plugging in the upper and lower bounds to get pi squared over 8. This way, much, much quicker. So I'm also going to do something else I don't normally do on this channel, and that is actually work out a problem on the board. I'm not going to have it pre-worked out for you. And what I want you to do is pause the video and try to evaluate that using the special case of King's property. All right, so hopefully you paused the video and tried that yourself. So now what we're going to do is apply the special case of King's property right here to I. So, using King's property on this integral right here, we'll get that I is also equal to the integral from 0 to pi over 2 of sine x over cosine x plus sine x dx. So I hope you're seeing where this is going by now. All we have to do to find I is add these two equations together. Doing that, we'll get that 2I is equal to this plus this. And since they have the same bounds of integration and the integrand has the same denominator, we can just write this as cosine x plus sine x over cosine x plus sine x, which is just, hope you can read this, that, which of course is equal to pi over 2. So now we know that 2I is equal to pi over 2. So dividing both sides of that by 2, we get that I is equal to pi over 4. So an extremely difficult integral made extremely easy using the special case of King's property. Hope you enjoyed that.